All right, welcome, welcome everyone. So let's see, it should be, I guess this is the way it's going to be. Cool. So debug now, zapping bugs out of PowerShell. Before I get started, in the description it was very heavily focused on debugging games. I've slightly shifted from that. We're going to get into a couple of different topics as well. So if you were here specifically for the gaming, I'm sorry to disappoint. So a little bit about myself. My name is Jaap. I'm very happy to be back here again, be back in person. So it's been really great to see a lot of familiar faces, but also a lot of new faces. One of the things I liked yesterday is the fact that most people that were at the keynote session were actually new people. So don't be afraid to step up to people during the conference, because it's a pretty great community that the DevOps Collective has built here. So a bit about myself. I'm a senior developer advocate. I'm a PowerShell enthusiast since, well, probably realistically since 2008, but I've been working with it since PowerShell 1. I wasn't one of the original people that got started with the pre-release versions. I work at Harness. We do CI/CD, and let's get into the session today. Before we get started, just to get an idea for the room and the level of experience people have here. So how many of you have been working with PowerShell more than 1 year? 3 years? 5 years? 10 years? All right. Oh, that's a pretty good experience level. And then again, doing it for 10 years, you still might not be very good. I'm a prime example of that. I've been doing it for almost 15 years and I can barely get by. Cool. So the topics for today, as I mentioned, I'll talk a bit about testing, testing in PowerShell. Which framework do we like to use when we test things in PowerShell? Anyone with a turtle? So we use Pester for that. Pester is great for unit tests, integration tests. I'll talk a bit about my experience, not only with writing Pester tests, but also trying to convince others to get onto the train of writing unit tests. And one of the reasons I picked that one up is because when I first heard about unit tests, I was very adverse to the idea of testing my code, because I knew that if I would press F5, my code would run and it would just work, right? And I was like, why would I write additional code on top of that? That just seems like busy work. I like busy work, but not when it's things that I don't like doing. So after starting to understand the value of that myself, I had an even tougher challenge, and I was trying to convince others to also get onto that train and to actually start writing unit tests. And I'll talk a bit about the process I went through there and how I managed to turn that ship around. Then we'll dive into a bit of error handling within PowerShell, and then finally we talk about debugging, and then specifically some of the debugging options that we have available in VS Code, because VS Code just makes it significantly easier than it was in the console. Does that sound good? Yeah. And I won't try to keep you too long, because lunch is coming up and I skipped breakfast, so I'm definitely ready for lunch. That's how I stay skinny. So let's talk about testing, and then let's talk about the challenge that I faced in regards to testing. So this was at a point where I was already familiar with PowerShell, with Pester, with writing unit tests. And my challenge was that I worked in a large organization, and I inherited a code base of a pretty big PowerShell project. The code was not owned by a single entity within the org, so that always makes it fun, because then you have to deal with all the different teams that are involved, and also people that you can't just tell what to do, so you need to get them on board. And there was a significant amount of rewrites of the code required, and there were also varying levels of code quality within the code base. And in order to make sure that that became more professional, I had a team of developers that would work on it, and then also the outside contributors that needed to be taken on board with the new testing strategy. So how we got there? The requirements that I set at the start was to make sure that code coverage increased. Is everyone familiar with the term code coverage? See, yes, no, yeah, of course, Justin. But thank you for participating. So code coverage is when you have a function, for example. Pester and other frameworks, they can calculate if what percentage of the code is actually being covered by tests. You can very easily fudge those numbers by writing bogus tests that cover the entire code. But when used appropriately, you can get a good idea of what portion of your code is actually being tested by the test that you have written. And when I started on this, with this code base, we had a code coverage of 2%. And for those of you that are not very familiar with what that means, that is not a good number. So the goal we set was to at least get it up to 80%. But just getting the number up is not the most important thing, because we also needed to make sure that the tests actually make sense. Because it's very easy to write a lot of unit tests that don't really do much. For example, when you create parameters and you put a parameter validation on there, like it has to be a string or it has to be a number in a certain range, you could write a unit test for that, but yeah, that unit test will always fail or succeed unless PowerShell is broken. So those kind of tests are not very valuable. So we put together proper guidelines in order to make sure that the test actually made sense and would test things that are important for the product. We made it mandatory for whenever a pull request came in, just to make sure that the new functionality also got the appropriate unit test following those guidelines. And finally, we were using a lot of private functions, and also the private functions, so the ones that were not directly exposed to the end users, they also needed unit tests, and additionally, they also needed documentation, because they were not very well documented, or not documented at all. So in general, the testing approach that we followed was first take a look at the flow of the function, see what the goal of the function is. Like if there's multiple if-else statements, make sure that every part of the path that your code can take to the function, there's going to be proper tests. So if you have a test, if you have a function where you have like 4 branches where you can go in 4 different directions, or 4 different operations can be performed, make sure that you accommodate for that in your test. Also decide what kind of aspects you want to test. Like I mentioned before, if you're just going to test for simple things that are covered by other aspects of the language, like parameter validation, there's not a lot of value in that. So test the things that matter for the code. And from that moment on, write the test to verify that those different portions work. And then also validate that they work as intended. And the validation part is particularly important, because at one point I started writing new functionality for that module, and I wrote the functionality, but the test kept on failing. So I got really upset with the test. So instead of taking a look at the error messages of the test, I was like, this stupid test. And I was admin, and I could just push through my changes even though the pipeline had failed. I was like, you know what, I'll just comment out the test, and I pushed the code online. So I pushed the code online. Sorry, question?
I was just going to ask, you mentioned that testing the parameters wasn't something that you should do as part of the entire debug process? You should put a lot of effort into it, is that?
Well, I mean, it depends what you test with the parameters. It can be valuable to test the parameters and to like execute your function with multiple parameters. But what I meant specifically, if you have a switch parameter and you're going to put in a string, well, you know what the behavior of that is going to be. So.
I think to put another way, like there's not a lot of value in writing a test that says, you know, like the dash test parameter fails when you try to give it a string as opposed to a boolean. Like you can if you want, but like since you've already defined it as a switch, like it's sort of already implicit in there. Like you can't accept any other values. That's kind of what you're saying.
Yeah, that's what I'm saying. Like with parameters, you can also put validate not null or empty, and then you put in an empty, you put in a null. Well, you know what it's going to do, unless PowerShell is messing up. But yeah, if PowerShell is messing up, then testing with Pester is not the way to go. Does that make sense?
Yeah, no,
Oh, and to repeat the question was, is there no value at all in testing parameters? There's definitely value, but you need to choose what to test. Right, to get back to the part, I had a test. The test failed. I had new functionality. I had like run my code, and I thought, well, that looks glorious, because I'm always very confident in the code that I write. I'm very critical of other people's code, but my code is always fantastic. So I pushed it through, it goes online, people start playing with it, and they start reporting errors. And then I went back to the test that I had commented out, and it turned out that the test actually did spot an error in my code that I didn't see. So there's definitely value in testing, and that was one of the moments that I wasn't very proud of my decision-making path that led me to that point. So then the second part was, I had the developers that were in my team. We're working on this together, but we're also, oh wait, the last block, that color is not correct. Anyway, so in order to educate other contributors, we made sure that our contribution documentation was up to date. If you were in my session yesterday, you might have heard me say that as well. Making sure that contributors are aware of what is expected of them was an important part of this as well. So we made sure that not only we documented that testing was required, but also where they could find the resources and what the expectations of the different unit tests was. Aside from that, we also put aside time to do enablement sessions, like teach people this is what unit testing is. This is Pester. Pester is very fancy. You can install it. It comes with a turtle. And it will test your code and it will make things better for everyone. In order to describe the flows better, what we did was we made specific documentation in which we discussed, like, okay, this is how the flow will go to how the code will flow to the function. So this was a simple function. It didn't have any branching. You get the credentials, you connect. In this case, it would take some parameters, but not all the parameters would have to go into the next command in order to get the data set, build a hash table, and then send the response out. So it was a very basic function, but by putting together those kind of flows, we would make it easier to explain to others, like, this is what we want to test, and this is what we are trying to achieve with these tests. So have a bit of visualization there. Does that make sense? Cool. So that was the part about testing. So let's get a bit into error handling. Error handling is quite, there we go. Error handling in PowerShell, we have a lot of different tools at our disposal. There's a lot of automatic variables and constructs that we have available. The most used one is of course try catch, but we have a couple of other tricks as well. So, since most of you are already experienced, how many of you are aware of the differences between terminating and non-terminating errors? Cool. So most hands are up, not all hands are up, so I'll still go over it. So the difference between terminating and non-terminating errors in PowerShell is both of them, if you have default settings for your console, will display red text. And as Sydney showed yesterday during the keynote session, there's like different ways it can be displayed. If you're on Windows PowerShell with the default error output, you'll get this big block of error messages with the squiggly lines. If you have the concise error view enabled, which is the default in PowerShell 7, then you get a neat error message. It will just display what is actually causing the problem. Most of the time. Sometimes it doesn't exactly tell you. So the difference between terminating and non-terminating errors is not what it displays, but it is how it is handled by a try-catch loop. So for example, if you do get item with an item that doesn't exist, it will be an error, but it's not going to be a terminating error. So that's the difference. The way you can force any error to be terminating is if you have an advanced function or you have a commandlet, then you can specify the error action, and you have a number of options there, and we'll go over that in a bit. But in general, you can specify either to continue or to stop based on an error. Then we have try catch finally. Most of the time I just work with try and catch. So in try you put any code that you expect to fail, and the catch block is what happens when the catch block gets executed when something fails. We have the default error variable, so all errors will get recorded there, unless you are running a commandlet and you specify a different error variable, then your errors will be stored in that one. And then we have different ways of handling errors. The way we can handle errors, we have $?. I don't have any chocolate anymore, but whoever gets this one right, and and you have to be someone whose name I don't know, because otherwise you're way too good at PowerShell. Yeah, you know who you are. What does $? Mean? In the back. Yep, that's correct. What's your name? Hans. Sorry? Hans? Okay, cool. Come up to me later on. I'll get you a bar of chocolate. I don't have it with me, but I have it in the hotel room. Sorry? Okay, so $? The last executed command, was it successful? So if your last command had an error, you can do $? It will return true or false. If you do $? Twice in a row, then the last command was $? And that was successful, so then it will become true. That's something to keep in mind. We have the trap statement. The trap statement is a bit outdated, but it's still nice to know what it does. You can put it usually at the top of your script. You can put some code in there for when an error occurs, and then the trap statement gets executed. Yes? Okay, I'll repeat the question. No problem. So the comment I got was the scope also matters. And the reason the scope matters, if you have code that fails inside of a function and you then run the $? It might not give the result that you would expect because the code failed in a different scope. So in general, scopes within PowerShell, you have different, let's see what the easiest way is. If you write function, you name it set variable, and you set a variable inside your function block, and you set a string in there, Jaap. You then try to read that variable. It will be null because it's not set outside of that function scope. The same goes for error variables such as $question mark. Then we have last exit code. Last exit code is mostly for legacy applications. So if you work with external tools, you can get the error code with last exit code. Doesn't always work as expected, but it is something that you can fall back on. Then we have error action and also error variable. So these are available for advanced functions or for commandlets, and you can change the behavior of when an error occurs. So you can change it from terminating to non-terminating or the other way around. And with error variable, you can put your own variable. So then we have a couple of preferences available as well. So all variables in PowerShell are also available as a PowerShell drive. And what I do here is just use getChildItem to display all the different preferences we have available. So we have confirm, debug. The ones we are interested in are error action preference, and another one that I like is verbose preference. So verbose preference is something that I often tell people to set before they run a script to make sure I get all the verbose information I need in order to be able to troubleshoot why their code isn't working. So it's a nice one to have. Yes?
I want to bring up a good point too, is that sometimes verbose preference will show you stuff that dash verbose won't, just due to weird stuff about how that inheritance stuff happens. So keep that in mind. Like just using dash verbose and turn on verbose preference sometimes leads to more. So that is an important distinction.
Cool. So we'll just mention that there is a difference between what verbose does and verbose preference. And I think part of the reason is also because it doesn't just apply to the commandlet that you executed on, but also whatever it calls underneath. I think that's where it comes from.
In short, I mean, I don't want to...
Yeah, no, that's fine.
In short, like it generally has to do with module scope. In the sense like you do verbose on this one command, then it's the scope of that command, but if that command calls another command, it's no longer in the scope of that command or in a different module, so it's not going to carry through the verbose. Whereas if you set verbose preference takes effect at the scope you set it at. So if you set it at your terminal, your process scope, it's going to take effect for everything that has a commandlet binding to it.
Okay. Process scope. Cool. So then we get to debugging. We have a couple of commands available. This is mostly if you're going to be running your debugging from outside of VS Code. So if you do live debugging from your console. So the ones we have available are set PSDebug. It's one of the older ones, but it allows you to set a trace command. If you set the trace command, you can actually go to, it will write verbose messages in which you can see the entire flow and every command that gets executed. So it's a nice and easy way especially for smaller scripts, to see what is actually happening when it's executing. The downside of it is if you have a script that's stuck in a loop, then you're going to see a lot of output, and yeah, because it's stuck in a loop, it will never stop. Then we have setting breakpoints. We can attach a debugger, and it's not a command; it's a tool. VS Code will give us a lot of options for debugging as well. And that's what we're going to take a look at now, is how we can use VS Code for debugging and some of the error handling things that I've just discussed earlier. Any questions before I get into that one? Is that a hand up or is that relaxing? Okay. Sweet. Cool. So let me know, is this good in the back or is this too small? It is a very hard audience to satisfy. So first thing first is just make sure that I clear my error variable. It's a new console, but I like to do it regardless. So first thing I do is actually show the difference between terminating and non-terminating. So what we have here, let's make sure it actually fits in the screen. So we have get item. This is going to throw a non-terminating error, and because of this, the catch block will not execute, and we will still see the error. You can see that we get the error, and we don't get the error caught message that we wanted. But because this is a commandlet, we can use the error action stop, and we can see if we run that, we will get error caught. But let's take a look at the error before we do anything else. So we have get error newest, so we can get more information about this. And then in particular, what we look for is, where do we see this? Yes, so we can see the error type as well. And this is something that we'll use later, so we can see drive not found exception. Before we continue though, we'll take a look at the error variable itself. We use error null, so we get the last error. And we can get more information out of that by using select object. You get something similar. Let's see. That one doesn't. Let's see. There we go. So format custom can be quite nice to get a lot of information out of it. So in this case, we can get a plain text dump of everything that is in there. And the other one is by using convert to JSON is also a good way to override the standard way that things are displayed in the console. And it will output a JSON object, and that will also give you all the information instead of the default of the error message, where it's either going to be concise view or just displays the error message. So the error message that we wanted to, the specific error type that we wanted to catch was the drive not found exception. So that's the one that I highlight here. So we can use the catch statement here to make sure to establish a certain condition here. Oh. I'm terrible with touchpads. So I'll select the code, execute it, and if I run this, it will say, are you running on a Mac? Because it says drive not found, because I was looking for :C, and obviously I don't have that. If I change this for something that would actually work here, so let's say does not exist, we'll get a different error type, and it would now just go for error caught. So because we have a different error type now, it will just go for the catch all. So that's the catch where we don't specify the error type, and you can put as many different catch conditions there. Try catch also. Yes? Yeah? Sorry, what kind of exceptions? I wasn't going down to that level. So the question was, am I going to talk about the base exception? No, I wasn't going down to that level. But do you have a specific question about that? Okay. Mm-hmm.
Because you haven't filed an issue on it in the PowerShell repo yet.
No, no, it's good, but yeah, I don't know why sometimes they are, sometimes they aren't. But about this code block, so we can line up as many catch blocks. They will function as if, else if, and the last catch block is just going to be the else block, or if you're using a switch statement, that would be your default. The nice thing is you can also keep on iterating inside of your catch block. You can throw another try catch block inside there, and you can make the rabbit hole as deep as you want it to go. So for the next one, we'll just invoke a lot of errors using throw. For the bonus question, is using throw to throw errors, is that in general a good idea or a bad idea? Who thinks it's a good idea? Okay, who thinks it's a bad idea? Why is it a bad idea? Anyone?
I found that whenever I use throw, the error message, the error reason I get is because you invoke the throw, not the custom error message that are created or anything like that.
What? Yeah.
Well, I mean, there are different ways of calling throw, but generally if you do a throw, what it's doing is it's creating a system.exception, and the message property of the exception is what you put in there. So you don't get as much random information. If you write error, you can populate the error record yourself. So I don't know, maybe that's not the stance you're looking for, but you have more control with write error
But,
than you do with throw.
yeah, so the comment you gave is you get more control over how you construct the error message and what kind of messages you can throw.
Build the error record with throws, like I said, you can pass in an exception object as an argument, or you can pass in a string, and that's basically what you're doing there. And the string is like, it's just the message property of the system.exception object, and so it's not on it anymore.
Yep, that's correct. One of the problems with throwing it as well is if you're going to throw, and that was going to be what I'm going to show here. If you throw, it will just stop executing as well. So if you have a throw function anywhere inside of a module, if it's going to be in your first command, then the rest will no longer execute. And no. Well, I mean, yes, but. So if we want to catch that error indeed, in this case I won't use a try catch. In this case I will use trap just to show how trap will work and how that can be useful when you're going to run code in which multiple commands can throw errors. So what we can see here, if we trap the throws, then we can still see the exceptions, and it will also execute whatever code, in this case, oh no, inside of the trap block. So if you do get item get PowerShell Summit, it will fail. So then we use $$ question mark. We can see false because the last one wasn't executed well, and the next one is going to be true. And I think the only thing that I still want to highlight of this one is if we want to see the different action preferences that we can set, we can get the enum names. So we have silently continue, stop, continue, inquire, ignore, suspend, and break. And these are also can also be converted to integers, as any enum can be in PowerShell. So a nice way to make that shorter for silently continue would be 0, stop is 1. Those are usually the most common, the ones I use most commonly. So if you want to use that, in this case I use get item. Shouldn't use aliases, VS Code is right there. So if I execute this one, we no longer get an error message, even though I do get item. And if I do stop, then we will get the error message. And with that, let's go take a look at my breakpoint script and see how that will, how we can work with debugging and how we can set breakpoints and what it looks like in VS Code. So we have a small script here with a pattern block, and all it's going to do is going to access get process, and it will tell us what's going on. It will either find it or it will not find it. So in this case, we run not a process. Oh, I'm not in the right folder. Let's see, demo. There we go. So I'll execute not a process, and we can see cannot find that process. So we'll set a breakpoint in there. You can see line number 4. You can also do this to VS Code itself. Now if we run it, we'll get into the debugger, and I'll collapse a couple of these things or make the site slightly bigger. So we can see here is we can see what the name was. We can take a look at which command was executed and where it was executed from. The zoom makes it a little bit hard. And here we can also see the different scopes that were mentioned earlier. So we have the local scope and what's defined in there, the script scope and the global scope. And these are all different levels in which the variables that can be defined, and that can also determine why a script is failing. So you can dive into that here. You can step through the script to debugging here, and you can use that to find the errors inside of your scripts. And with that, so we talked a bit about testing strategy, not only like how you can do your how you can run your test, how you can create your test, but also how you can do it within a larger team and get people on board with writing unit tests, integration tests, and making sure that those guidelines are actually followed. Then we talked a bit about errors. Got a bit into the different scopes and different ways of approaching error handling in your script, and showed what we can do with debugging from VS Code and how you can step through that. And with that, any questions remaining? Yes. Was it clear to everyone, or shall I repeat it?
You might want to repeat for the recording.
Oh, right, yeah, right. So I set it on a breakpoint, but there's also different places where you can set it on. So for example, on a variable or on a specific command or specific places in the pipeline. Is that a good summary? Yeah. Cool. Well, in that case, thank you very much and enjoy lunch.